parity bit, the bit which is added to a sequence of bits to make the total number of ones in that sequence either even or odd. So we can tell that we have a sequence of bit, and in that sequence we are adding extra 1 or extra 0 depending on how we want the sequence to be. Like either we want the number of ones in the sequence is even, or either we want the number of ones in the sequence is odd. To accomplish this target, we add an extra bit in the sequence. We may append it or we may prepend it, that doesn't matter, but this extra bit is called the parity bit. So this is the general definition for parity bit, but there are two kinds of parity bits. One is even parity, I have discussed it first, and then the second one is odd parity. So let's come what is actually even parity. It is written here that if adding the parity bit to the sequence makes the number of ones in the sequence even, it is called even parity. So what this actually does, it is that we have a sequence of numbers, actually that is the sequence of bits, zeros and ones, and suppose in our sequence the total number of ones is even, then we make the parity bit 0, because we already have an even number of ones in that sequence. Again, we may make the parity bit 1 if in our actual sequence we have odd number of ones. Now it is time to discuss odd parity. What is actually odd parity? If adding the parity bit to the sequence makes the number of ones in the sequence odd, it is called the odd parity. So what is actually it is? So that is, we have a sequence of bits, that is zeros and ones, and in that sequence we have odd number of ones. So we make the parity bit 0 because we already have odd number of ones. But if we have even number of ones in that sequence, then we shall put an extra 1 as the parity bit. So if we add an extra 1, then the total number of ones in that sequence will be odd. So here comes 4 examples for us. There one thing should be mentioned first. Our main sequence is called the data word, but when we add an extra parity bit like this, highlighted in the gray sequence, that will be, then that parity added sequence will be called code word. That is why I have written here code word, highlighted in the green color you see, and I have written here data word, highlighted in the green color, and also I have mentioned a P here. It is actually our parity place. First of all, here is actually nothing, guess. So our sequence is 1 1 1 1 0 0 0 0, that is tetra 1 tetra 0. First, for considering even parity, look out that there are 4 ones. So we already have even number of ones because 4 is an even number. So as our parity bit, we can choose either 0 or 1. But since we have a parity bit we have an even number of ones, so our parity bit will be 0 because in our sequence we have already even number of ones. Next, consider a second example. In this example, our data word is 1 0 1 1 0 0 0 0. We see that in this example we have in total 3 ones. So the number of ones in this sequence is 3, which is actually an odd number, but we want even number of ones in our sequence, that is in our code word. So our parity bit at this place will be 1 because we have 1 shortage. So that parity bit is placed 1 and our new code word is 1 1 0 1 1 0 0 0 0. So this goes for even parity. Now comes the example of the odd parity. Look for the data word in our example 3 highlighted in the yellow color. Here this place is preserved for the parity bit, and this is our actual data word, which has in total 4 ones. So we need odd number of ones. Since 4 is an even number, we add an extra 1 as our parity bit here. So in total in our code word there are 5 ones, which are these. So this is an odd parity. Again, look for our example number 4. In this example we have 3 ones. Good. Our data word is 1 0 1 1, then tetranote. Since we want it to be an odd parity, so at this place, which is preserved for our parity bit, will be 0 because we already have odd number of ones. So in our code word our parity bit will be 0. So our code word will be 0 1 0 1 1 0 0 0 0. And to mention you further, I can say, or I can inform you that parity bit is widely used in data communication for correcting and detecting errors. This is widely used in Hamming code. I shall discuss about Hamming codes in our next episode. Thank you all for watching this tutorial.